So previously we have discussed about contiguous memory allocation. Okay, so we have seen the problems: one, internal fragmentation; two, external fragmentation. To avoid external fragmentation or to overcome external fragmentation, we have seen a concept called compaction. But the problem with compaction is it degrades the system performance. Okay, so instead of storing the process at only one place, okay, it's we will go to non-contiguous memory allocation, where we will divide the process. Okay, we divide the process memory and we store in the different areas where the memory is available. Okay, so we don't need to store the entire process. We need to check if there is a 50 MB process, and we need to find the whole, or we need to find the partition which in which that particular process will fit into. Okay, so instead of that, we'll divide this particular process and into multiple partitions. Okay, so some particular portion of the process will be stored into some place, and some particular portion of the process stored into some particular place where how much amount of memory is available. Okay, so there is there are certain rules. Okay, we need to split and we need to store it onto main memory. Okay, so there is a mechanism called paging. We will discuss about this one. Okay, so there are some rules here we need to follow to this particular paging. Okay, so paging is a non-contiguous memory allocation. Okay, why we are using paging? To avoid the problem of external fragmentation, and this particular external fragmentation is also much more wastage of memory. Even with internal fragmentation, external fragmentation also wastes some memory. Okay, so here in paging there are two things. First one, there is a process. Okay, the process combines with your program and data. Okay, this particular thing is stored in your hard disk. Okay, the process memory, where this entire process memory is stored on the hard disk. Okay, so this particular process memory and this particular main memory, that is your RAM. Okay, so there may not be the same memory. That means RAM, in general, current versions of RAM that consisting of minimum to minimum 2 GB RAMs are there. So 2 GB, 4 GB, 8 GB RAMs are there. Okay, so when it comes to process, the process alone, suppose that a movie file .mp4 is there, .mp4 movie file is there, some particular movie file x.mp4. The file itself is either 1.4 GB or 2.8 GB. This particular 2.8 GB, you need a software to run it. Okay, the application program to run it. Example, some particular player. Okay, some particular player. So you need to load this particular data file into this particular player, and you need to run that particular movie. Okay, so this itself may be 200 MB or something. So one process itself is 3 GB. One process itself is 3 GB. If you take a 2 GB RAM, okay, you cannot load one particular process. Okay, so that's why we'll divide this particular process. Okay, that which data along with your program, we'll divide this into some smaller partitions. We'll divide this into some smaller partitions. Okay, the process is divided into smaller partitions. We'll call those partitions are pages. A process is divided into pages. Okay, similarly, main memory is also divided into equal number of partitions. They are called frames. They are called frames. Okay, so process is divided into pages and main memory is divided into frames. Main memory is divided into frames. Okay, so the process, this is your process. Okay, but there is a condition in dividing pages and frames. What is that? The size of the page should be equal to the size of the frame. Both should have same size. That means a process p1 is 100 bytes. Okay, we have decided that this particular process, okay, the operating system decides that all the process will be divided into pages. Okay, and this particular page size is 10 bytes. Okay, then this particular physical memory is also divided as 10 bytes. Okay, if the process operating system decides that it will be 10 kb, then page size is 10 kb, the frame size should also be 10 kb. Okay, so if you divide a process with 5 kb each page size and frame number is 10 kb, this will not be happen. If the page size is 5 kb, the frames is also divided into 5 kb. Okay, right? So there is rule called page size equals to frame size, so that whatever the one page can exactly fit into one particular frame. Okay, 5 kb of page will be fit into 5 kb of frame. So all the frames will be having same size called 5 kb, 5 kb, 5 kb, 5 kb. They can be divided into same size frames and same size pages. Okay, so we need to maintain this particular pages. Okay, and remember that not all the pages are loaded, pages of memory are loaded into main memory. Okay, the and all the pages of this particular process, they are not all the pages will be stored into main memory. And one more thing, even you store all the pages where there are some particular small processes, even you store entire small process into main memory, there is no rule that you can store it in a contiguous memory. Okay, you can store it in different places, you can store it in different places where the memory is available. Okay, when the pages are loaded into main memory, when the pages are loaded into main memory, they may be loaded into different places. So that's why we need to maintain a page table as well as a frame table. Okay, there are two tables we need to maintain, a page table and a frame table. What page table will do? Okay, the page table, there is each page number. Okay, the page table consisting of page numbers and frame numbers. So this is your frame numbers, this is your frame numbers. The page numbers acts as index to page table. Page numbers acts as index to page number. That means 0 1 2 3. Assume that there is a process. Okay, and it is divided into 4 pages, p0, p1, p2, p3. Page 0, page 1, page 2, page 3. Now page 0, okay, page number 0 is stored at the first frame, frame number 1, and page number 1 is stored in frame number 4. Okay, page number 2 is stored in frame number 3, frame number 3, and page number 3 is stored in frame number 7, frame number 7. Clear? Okay, so we need to maintain a page table as well as frame table, page table and as well as frame table. What page table consisting of? Page table consisting of a page number that is indexed to page table. Each corresponding page will have a frame number. Okay, page number and frame number. There are other attributes also associated with the page table. As we are moving on to next topics, we can see what are the different fields that are associated with page table. Until now, remember that there is a page number. Each page number is associated with one particular frame number. Okay, so this conversion of page number to frame number is also called binding. Okay, address binding. This conversion of page number to frame number is done at execution time binding. We will discuss this particular thing later. Executable time binding. Okay, right? So where this particular frame tables and page tables are stored, this particular frame tables and page tables are stored in main memory, are stored in main memory. Okay, right? So page table and frame table, page table and frame table. So in our PCB process control block, there is a register called page table base register, page table base register, which points to page table in the main memory. Okay, which points to a page table. Then there is something called page table length registers, page table length register, which stores the size of the page. Okay, which stores the size of the page. Okay, right?